Hey everybody, today we're going to work on transformations lesson number 3, otherwise known as a rotation. Now the idea of a rotation is you could do anything. You could take a happy face, you could rotate it. You could just say, okay, I'm going to take this thing right here. Okay, it doesn't have to be complicated. We're just going to take something like that. If you were to rotate that thing 90 degrees, you would get that. So now I'm not really sure if it's happy or not, but it's definitely there. The idea of a rotation is we're just going to kind of turn something. We're going to turn it a certain number of degrees and see where it lands. All right, now, the first rule that we're going to deal with here is 90 degrees about the origin. Now, by the way, if you're talking about math code here, you're going to see a lowercase r followed by the number of degrees and then a comma. And then kind of this O looking thing, otherwise kind of like a zero looking thing, that implies that we are rotating about the origin. Now, here's what it's going to look like. 90 degrees means we are going to rotate your figure, and this is where people are going to mess it up. We're going to rotate our figure 90 degrees that way. Now, some of you might be looking, you're like, what in the world? Why would we do it that way? Just pay attention here. We'll talk about why. Step 1, you're going to make a line segment that goes from the origin all the way to point A. Okay, so that's what we'll do, and we'll just do that in red right here. We're just going to take a line segment. We're going to go from the origin to point A. Now, this is where people get confused. The rule is if they don't tell you which direction to go, the expectation is that you go counterclockwise. All right, now, this is where people are going to make some mistakes too. If we want it to be counterclockwise and make a 90-degree angle, that means the new segment that we make is going to have to be perpendicular. Kind of cut off a little bit there. I'll move it up. Make a new perpendicular segment that has the same length as the original line. Okay. So here's what you need to do. You need to take that line that you created, and you need to make a new line the same length, and it has to swing along 90 degrees. So you have to basically swing that line around until you get a perfect 90-degree angle. Now, at this point, a lot of people are like, well, how do you know it's perfect? Well, there are two different tricks that we can use to make sure that what we did was exactly right. Trick number 1. This line here was up 2 and then to the right 5. This was down 5 to the right 2. So again, you're talking opposite reciprocal slope right here. Okay, and by the way, we were supposed to rename the point as A prime. Right now, there's another trick that might help. I don't know if this is going to help you or not, but I think it would be a great trick, and it actually involves your paper. One thing you can do, if you want to take your sheet of paper, instead of turning your point counterclockwise, you could actually turn your paper clockwise instead, and then go to the same ordered pair that you were at before. Okay, so let me show you how this would work. Right now, you look at point A. Where is point A? It is at 5, 2. Okay, so if you were to take your coordinate plane, so basically you're just going to take your paper, and you're going to turn your paper 90 degrees to the right and then go to the point 5, 2. Look at what happened. We found it. We found what we were looking for. So again, what I'm asking you to do here is if you want, instead of turning your figure counterclockwise, you can actually turn your paper clockwise, and you will get the result that you're looking for. So those are two tricks that can kind of help you along your way. So again, you could either base it on slope and make sure you get what you're looking for, or you can actually turn your paper the other way. Okay, so hopefully that visual helps. If it doesn't help, that's fine. We'll practice a few more times and we'll see where we go from there. All right, rotate 180 degrees. Now 180 degrees doesn't take a whole lot of effort. We're going to start the same way. We're going to go from the origin to point A. And then we have to ask ourselves, what does it actually mean to be 180 degrees? Well, 180 degrees is just a straight line. It's a straight angle. So all I really have to do for this next example is continue the segment the same length that we had it initially and just go past the origin. So all I have to do is basically take that line segment that I drew from the origin to point A and then just go exactly the same distance in the other direction. And what I create when I do that is a straight line, and that straight line will lead me to my goal. Okay, so that is rule number 2. Now, you might be wondering about the paper trick. Does the paper trick work? So again, what would I do to my sheet of paper if I wanted to do the paper trick for this problem? Well, 180 degrees would be the equivalent of turning your paper upside down. So, what ordered pair did we start with? It was 5, 2. So if you turn your paper upside down, you can actually do that right now. Even though I'm just talking to you through a video, you can still do it. If you turn your paper upside down and then go to the point 5, 2, guess what? We made it. Kind of a cool little trick. You can kind of take it for what you want. I think it's helpful. A lot of kids have had a lot of success doing it that way, so we might as well go with it. All right, rule number 3. We're actually going to do rule number 3 on the same coordinate plane that we did rule number 2, just to save space on our paper. Now, 270 degrees. If you look at our first example, that was 90, and then 180 put us right here. 270 would just be a continued process here. So if you're a quadrant person, we were in quadrant 1, then we made it to quadrant 2, then quadrant 3, and now all of a sudden we are at quadrant 4. I don't know if that helps, but some people know their quadrants, and it helps to see it that way, maybe if you're good at that. Now, what that means is that if we were to do 90, 180, 270, we should land somewhere over here. But we don't really need a new rule. And the reason we don't need a new rule is because 270 counterclockwise is actually just the same as 90 clockwise. So instead of worrying about going here and then going here and then going here, that would be silly. All you really have to do is go 90 clockwise and you will get what you need. So you can actually take the same method that we did, but just do it backwards. So that's what we're going to do. We're going to take our original line that we had between the origin and point A, and then we're just going to swing that line over, and that will get me my new A prime. So again, if this particular coordinate plane looks a little bit ugly, it's because we were demonstrating both rule number 2 and rule number 3 on the same plane. Now again, I think the paper trick is worth discussing here. If you want your figure to go clockwise, then you would want to turn your paper counterclockwise. Okay, so if you were going to do the paper trick for this problem, you would take your paper and rotate it counterclockwise, and you would get what you are looking for. So any of you who are doing the paper trick, turn your paper this way and then go to 5, 2, and you will find where you need to go. All right, now, real quick, if you're looking at rule number 4, 360, well, when you do a 360, nothing really happened. You should have landed directly back at your starting point. So assuming you did your 360 correctly, there was really nothing to do at all. Okay. All right. So for this next one, we just want to practice what this would look like if we were dealing with not just a point being rotated, but an entire figure. So take a second. If you have to stop the video for a second, you can, but we need to practice what would happen if we took that figure and we rotated it 180. All right. Now, in order to do that, remember 180 is the measure of a straight angle. So we just need to figure out our distance from the origin to each point and then continue it that exact same distance. And that will be our official rotation here. So basically 180 is we're going to rotate this direction. That's what we're going to do. So we go over here. If you went from the origin to point C, that would be 4 units. So that means I would have to extend it 4 units down. And that would put it right about there. And then point B, kind of the same idea. You would want to draw a line from the origin to point B. And then whatever distance you traveled, you need to travel that same distance. And that should put you right there. And this will be your B prime. So we have our B prime. We have our A prime. And then we have our C prime. Connect those and you should have your new rotated figure. So you can see one of the things that makes it weird is C used to be up high, now it's down low. And so you can kind of follow along where that rotation actually happened. All right, now example 2, there is an A and a B, so I want you to draw that trapezoid twice, and we are going to practice 2 different rotations, one on the first and one on the second. So you pause the video, I'm actually going to pause mine, and I'm going to draw the trapezoid on mine just to save time. So I'll join you here in just a second, and I want you to do the same thing when you're ready. Check your work, and we'll see where it ends up. All right, so I'm back here. I added in my 2 trapezoids, and we're going to do a 90-degree, and we're going to do a 270-degree rotation. Now, if you like the paper trick, this is definitely for you. Now, a 90-degree rotation, and that's what A is, it's a 90-degree rotation. It should put you counterclockwise somewhere right over there. Now, we could do the line thing where you draw a line connecting point P to the origin, and then you make a 90-degree angle, and that'll be your new point P. That's a great way of doing it, and you could do it for all of these. If you are a paper trick kind of person, let me demonstrate what that would look like. Remember, if you want to swing your figure counterclockwise, you would need to swing your paper clockwise. So that's what I want you to do. I want you to try this out. Let's try this once and see how we do. Take your paper, and I want you to turn it to where the hole punches are on the top. Or if you don't have hole punches, just turn your paper clockwise half a turn. And watch how quick this goes. Your original point P was 1, 1. So now go to 1, 1 on your flipped version. Ignore the labels, just go with your gut. 1, 1 would be there. 3, 3 was point Q. That would be there. So let's label them as we go. P prime, Q prime. R was 4, 1. So go to 4, 1. Make a dot. And then S was 3, 0. So go to 3, 0. And make a dot. Now, you won't necessarily know whether you are right or wrong with all your work until you turn your paper correctly again. And then you look and you're like, well, did I go to the quadrant that I was supposed to go to? Turns out, yeah, absolutely you did. We knew what we were going to do. I actually think drawing an arrow right off the bat is not a bad way to go because it kind of forces you to think about where you need to be headed. Okay, so that was the paper trick. I don't know if you liked it, didn't like it, but I think it's a little bit easier than having to go from the origin and bounce back up, and then origin, bounce back up, origin, bounce back up, origin, bounce back up. I think it's easier to just turn your paper and go with it. Might be just me, but that's what I'm going to go with here. All right, last but not least, I want you to try to rotate 270. Now remember, you could go 90, 180, 270, but that would just be silly because 270 is really just the same as 90 clockwise. Now, if you want to do the paper trick, remember, if you want your figure to go clockwise, then you need to turn your paper counterclockwise. So now I want you to have your paper turned to where the hole punches are on the bottom. And then once you're there, I want you to try again. I want you to go to the point 1, 1. I want you to go to the point 3, 3. They're listed for you on your paper if you're not sure. 4, 1. And 3, 0. Label them how you want. It might make more sense to wait to label until afterward because then you would be able to have them facing the right way, but I don't care if you don't care. We're okay to just do it like that. Connect the dots, and then at the very end, it's important just to make sure you drew it right. So in the end, just make sure you turn your paper over, take a good look at it, and then you can sort of decide for yourself, did I actually accomplish what I wanted to accomplish? Did I end up landing my figure on the quadrant that I wanted it to? Turns out it looks really good to me, and what we have here is a 90-degree rotation and a 270-degree rotation. So again, I don't know if that paper trick helps you where you actually turn your paper the opposite way of what you want to go. I've seen a lot of kids have a lot of success with it lately, so hopefully that steers you in the right direction. If you didn't like that, then you can always do just the angles from the origin straight out, and that will also get the job done. Remember, 180 is just a straight line, so that one you don't really have to think much or turn your paper unless you want to. Anyway, I hope this helps you out. Get started, see how it goes, and have a great day.